Hello, 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 everybody. Welcome to Math for Today. Happy Thursday. Here we go. Fraction times fraction. What we've been building towards. I even wore the right shirt today. Heck, I love math because we're doing fraction times a fraction today. This is what it's all been building to. All of this work. Multiplying whole numbers by fractions. Multiplying mixed numbers by whole numbers. Multiplying whole numbers by whole numbers back in 3rd grade and 4th grade. Now we're here. Fraction times a fraction. What does it mean? What does it look like? How do we do it? We're going to get started on that today. There's what you'll need, the usuals. And then down here we've got 3 I cans. I'm going to read them for you. I can explain how multiplying by a value of less than 1 will give a smaller product, which we're multiplying by values less than 1 today because we're doing fraction times a fraction. We're no mixed numbers, no whole numbers today. Just fractions greater than 0, but less than 1. So we're only working in a small space on the number line today. I can draw a model to visualize fraction multiplication, and I can use an algorithm to multiply 2 fractions. Okay, so let's start with the visual. Now, reminder, as a general reminder, when we're thinking about multiplication, we're thinking of blank groups of blank, right? 6 groups of 4 would be 6 times 4. 3 groups of 2 would be 3 times 2. So it's not any different when you're multiplying fractions. It's just can get a little bit tricky to visualize because we're dealing with less than one group. We're dealing with part of a group. In this case, with 1/2 times 1/3, we're going to start here with 1/2 times 1/3. In essence, we're saying 1/2 groups, or 1/2 of 1/3. Okay, my value here is 1/3. Maybe it's 1/3 of a mile. Maybe it's 1/3 of a bag of cookies. Maybe it's 1/3 of a pizza. We're going to take that value, we're going to cut it in half, and then what's the value of 1/2 of that? 1/2 group of 1/3. If we're going to visualize this, we're going to take 1/3, we're going to cut it in half. And then how much is each half? Now hold on. I know I want 1/2. So I'll shade in 1/2. I want to know how much this is. But so I know I have one piece. It's going to be 1 something, right? Because I only have 1 piece. But what's my denominator? How do I figure out the denominator here? Because the denominator refers to how many pieces we're going to need to put together to make a whole 1, right? So let's try this a different way here. Rather than taking our fractions bar and making it the value of 1/3 and just cutting it in half, let's try this. Let's take our fractions bar, and instead, we're going to make this 1. This fractions bar is going to equal 1. And then we're going to start with cutting it in thirds. So now I know I have 1/3, 1/3, and 1/3. Okay? Then what I can do, now I'm going to cut this in half. And in order to know how many equal pieces I'm making, I'm going to cut all of them in half. So now in my 1, how many equal pieces have I divided this 1 into? 1, 2, 3, 4, 5, 6. So I know each one of these pieces is 1/6 of the whole. And in this case, because I'm only looking at 1/3, I only want to know half of 1/3, I can isolate my third here, and then 1/2 of 1/3 was how many pieces? It's 1 of our 6ths. because six of these sixths would make a whole. If we were to put this back together, each third cut in half makes sixths, or 1/6. Okay, let's try it with one more here. So we're going to take, for this one, let's try 1/4 times, let's go 2/3 this time. So now, again, if we just took our if we made this 2/3, cut it into 4 pieces, we'd know we'd have one piece of something, but we wouldn't know the denominator because we don't know how many pieces this takes to make a whole. So let's back up again. Oop. We're going to take this fractions bar, we're going to make it equal to 1, as we do. Okay. You could even think about it like a 1 by 1 square, right? Because it's going to have the area of 1. So maybe we'll drop more like a square. That's square-ish, right? If this length is 1, this length is 1, we have 1 in the middle as our area. Okay, if we're using an area model here. So now, let's think about this. Let's go divide this up into thirds. Okay. Start there. So we've divided this one up, this length of 1 up into 1/3 plus 1/3 plus 1/3, right? Which equals 3/3, which equals 1, right? Could be 1/3 of an inch, could be 1/3 of a mile. Okay? And we want to look at 2 of these thirds. So actually what I'm going to do here is I'm going to put little stripies, because I want to remember that I'm only focusing on these 2/3 for the purposes of our answer, because I want to know what is 1/4 of these 2/3. So now I'm going to take my 2/3, I'm going to divide them into fourths. Okay? And I'm going to extend this to go into my third third, because I do want to know, I have to know what how many of my pieces total are going to remake this 1, because I need to know what my denominator is going to be. So in this case, if I take thirds and divide those thirds into fourths, we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've made twelfths. We have made twelfths, right? 1/4, 1/4, 1/4, 1/4. Now, I want to know what 1/4 of my 2/3 is. So I'm going to take my 2/3. I'm going to erase my third here. You can leave it if you want, but I'm going to erase it just to make it a little more clear. So now I've got my value of 2/3, 2/3 times 1. Okay, and I want to know what 1/4 of that is. And I'm actually going to use stripies going the other way to show that now I'm not even worrying about this bit down here. All I'm worrying about is 1/4 times 2/3. And do you see here? Now I've made a rectangle that is 1/4 high and 2/3 wide. So now I know my area in the middle is going to be the answer to this multiplication equation, which is 1/2. And some of you are starting to notice a pattern here. We had 1/2 times 1/3 equals 1/6. We had 1/4 times 2/3 equals 2/12. And this gets us to our standard algorithm, or the most straightforward algorithm, for multiplying fractions is we multiply straight across. 1 times 2 is 2. Fourths times thirds is twelfths. 1 times 1 is 1. Halves times thirds is sixths, because 2 times 3 equals 6. Okay, so the shorthand version, and this was the version that I was taught in school, but it was the only way I was taught at school, so I had no idea what I was doing when I did it. I just went, 5/7 times 4/6 equals 20 40-seconds. But what does that actually mean if there's no context here? What I'm saying is I'm making a rectangle that's 5/7 long, 4/6 wide, and has an area of 20 40-seconds. Right? Very, very complicated. You probably won't see this out in the wild. You might see it on a math test, though, which makes me question the whole nature of math tests. If we're testing on stuff that isn't seen out in the real world, why do we even need to test on it? And shouldn't we be testing for things that are more useful? You know what? I'm just going to leave that there, get off my soapbox, and let's move to the digital whiteboard so we can think about a couple more problems here. Let's go. Hold on. Let me pull it up. Okay, we're going to start with this one. We have here 2/3 times 2/5. And I got a rectangle here, but I'm realizing that, you know what, I'm just going to redraw this as a square, I think. 2/3 times 2/5. Now you can start with the standard algorithm and didn't click in there, and multiply straight across to get an answer. But what we're also going to do is we're also going to prove it with a visual, so we can really see what's happening here. Okay, so we can go straight across. 2 times 2 is 4. 3 times 5 is 15. But let's confirm that. Okay, so we're going to take our square, and we're going to envision that this is a 1 inch by 1 inch or 1 foot by 1 foot square. We're going to take one side of it and divide it into thirds. Okay, so here are our thirds, right? 1/3, 1/3, 1/3. And we're going to take our other side and divide it into fifths. 1/5, 1/5, 1/5, 1/5, 1/5. And how many boxes, I know they're not mathematically even because I was freehand drawing it, but how many boxes are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, because there are 15 equal boxes, we know that each box is worth 1/15 of the whole. So that gives us our denominator. That's where our denominator comes from. We've divided this 1 by 1 box with 1 square unit of area in the middle into 15 equal pieces. So each piece is worth 1/15 of the whole thing. Now we need to know what is 2/3 times 2/5. So what I'm going to do is I'm going to shade in 2/3 and I like to use diagonal stripies because I can kind of see them even if I'm using the same color. 2/3, and then I'm going to shade in 2/5 because I'm only focusing on those bits. 2/3 times 2/5. Now, there's a lot shaded in here, but what we want to focus in on, right, is we had started with 2/3. So our third, or this bit here, we actually don't have to worry about this bit because we're only focusing on our 2/3 of our 2/5. Okay? And then, similarly with 2/5, right, we're only focusing on 2/5, our top 2/5 that we shaded in. So we actually don't need to worry about these bottom 3/5. How many pieces are we left with that fall into, that we're really showing 2/3 of our 2/5, taking our 2/5 and then shading in 2/3 of it. How many pieces? 1, I'll dot them in green, I'll count them in green. 1, 2, 3, 4. So there is our 4/15 of the whole. All right? Try it both ways. Yes, it is easier to multiply straight across. But try visualizing it both ways, because the more and more we work on it, and the more we're going to see fractions times fraction problems in story problems and in situation problems, you're going to want to have a visual reference, okay, of being able to take a 1 by 1 square, divide one side into thirds, divide the other way into fifths, take 2 of each, and end up with 4/15. Let's try one more. We have 3/8 times 3/4. 3/8 times 3/4. So again, take one side of your rectangle or square. In fact, I'm going to redraw it as a square because I do want to be closer to mathematically accurate, because technically this should be an actual mathematical square here. There we go. That's closer. Okay, you're going to take one side, you're going to divide it into fourths. Okay? You're going to take the other side, so this is fourths, and the other side is going to be eighths. Okay? So now we have how many pieces total? 4 times 8. We took our 1 by 1, we took our whole thing, we divided it up into 32 equal pieces. So our answer is going to be in 30 seconds. Now, what's our numerator? Right? So let's isolate 3 of our fourths. Just 3/4. We don't have to worry about the fourth. Just 3 of them. Okay? Now we want to take 3/8 of those 3/4. So 1, 2, 3. Okay? And then how many 30 seconds were shaded in both ways, right? We started with 3/4, and we want to know 3/8 of those 3/4. We end up with, put in gold, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 30 seconds, which confirms our algorithm of multiplying straight across. 3 times 3 is 9. 8 times 4 is 32. All right, everybody. Now, we're introduced to 2 different ways to multiply a fraction by another fraction. I would highly recommend using both, right? Drawing a square on a whiteboard or a piece of scratch paper, and trying that visualization method where you're breaking one side into one of your factors, the other side into your other factors, shading them in, using 1/4 of those 2/3. Right? 2/3. And we're just going to take 1/4 of those 2/3, which gives us 2/12. Okay? If you do it both ways and get the same answer, then boom, right? Trying things multiple multiple ways and using multiple strategies helps cut down on computational errors from going too fast or just misremembering a math fact, saying 8 times 8 is 63 instead of 64, right? If you do it both ways, you'll catch those errors more often. All right. Good luck on the exit ticket. Come see me in office hour if you have anything you would like to work on. It doesn't just have to be fraction times fraction. It could be fraction times whole number, mixed number times whole number times whole number. If you want to work division, if you want to work subtraction or place value, if you want to work decimal review, come see me in math office hour. Otherwise, I'm just sitting here bored. And I would much rather be working on math with you than not doing anything at all. So, happy mathing. Good luck. You can do it. I believe in you, and I will see you soon.